Hi, thank you so much for joining us for Elementary Edge Parent Workshop, where we will focus on the Common Core math strategies. My name is Erica Ritterman, and I am the owner of Elementary Edge Tutoring Company. Today, I will share a brief introduction about myself and Elementary Edge. Then we will focus on Common Core, the why. Why did we change math from the way that it had always been done to the way that we do it now? We'll walk through Common Core math, the how, and I'll take you through each grade level and show you how math is taught to your children at that age. And finally, there will be some time for questions and comments. So, a brief introduction about myself. I got my bachelor's in elementary education from Penn State. After that, I got my master's in special education with a concentration in autism spectrum disorders. And I'm currently on sabbatical pursuing another master's degree in curriculum and instruction. For the past 11 years, I've been a teacher in the Lower Merion School District, primarily in second and third grade classrooms. I am the parent of a 5-year-old little girl who is in pre-K and a 6-year-old boy in first grade. My husband and I founded Elementary Edge in 2020 to help families navigate the pandemic. And since that time, we have supported over 150 clients across the tri-state area. Moving on to Common Core Math, the why. Why did we change the way that we teach math? Well, with Common Core Math, there is a strong emphasis on number sense. Students use reasoning in real life situations. Using this math gives students a solid conceptual understanding, and they also have to show deeper knowledge in being able to explain how they arrived at their answers. In kindergarten, kids focus on a couple of main concepts. The first one is a term called subitizing. Subitizing means recognizing a set of objects without having to count them. So, for example, if you give your child 5 cookies and say, "How many cookies did I give you?" They should be able to look at those cookies and say 5 without having to count 1, 2, 3, 4, 5. Also, in kindergarten, the students are working on counting to 100 by tens and ones. And if your child has already completed kindergarten, you may remember a big 100th day of school celebration. So, starting on the first day of school in kindergarten, they count each day as it passes by ones. Then they group them into tens, and it culminates in a big 100th day of school celebration. Also, kindergarteners are learning to write numbers from 0 to 20. They are practicing comparing numbers as well as adding and subtracting through 10. One of the major emphases in kindergarten is adding all the ways to make 10. For example, the student should know 1 plus 9 is 10, 2 plus 8 is 10, 3 plus 7 is 10, 4 plus 6 is 10. And that's really going to help them as they get older working on more complex math problems. So, what does this look like in a kindergarten classroom? First, they use a lot of manipulatives. They will be counting with bears, Unifix cubes, any kind of chips, small objects that they can manipulate to count. They will also be using something called a 10 frame, which is a rectangle that has 10 squares inside of it. When all of the squares are filled, the students know that there are 10 objects. They will be using the tens and ones from base 10 blocks to show that the little cubes represent a 1 and the strips of 10 represent 10 cubes stuck together. And lastly, they will start using a number line. So this example is showing 8 plus 3 on a number line. So students will start at the number 8 and do 1, 2, 3 jumps to land on the 11. And when they do this, they don't need to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Moving into first grade, the first grade students are doing a lot of work with number bonds and splitting numbers apart, as well as focusing on fact fluency. In first grade, they should be able to count to 100 by ones, twos, fives, and tens, compare numbers using the less than, greater than, or equal to symbols, adding and subtracting within 100 using a 2-digit number and a multiple of 10, and they're going to start solving word problems in first grade. So the how. Now that they have a solid understanding of numbers through 20 and ways to make 10, they focus on number bonds and really manipulating numbers. So the whole goal is to use the number 10 to make mental math a lot easier. So this is actually a worksheet that my son brought home last week. And if you look on the left, number 1 shows 3 hands, and it says circle 10, write the number, and then how many tens, how many ones. So he circled 2 hands to make a 10, and then there are 5 left. So he's showing 15 is the same as 1 10 and 5 ones. And then looking at the page on the right, number 6, instead of using actual objects, they are showing just circles. So he circled the 10 and then saw that there were 2 left over. So it shows 12 is the same as 1 10 and 2 ones. And the picture that they're using is they use number cards in the classroom called hidden number. And that 2 is covering up where the 0 would be. So the students are showing that the 1 is really representing a 10 and the 2 is representing 2 ones. In first grade, they also are adding with 3 add-ins, and they're looking to find numbers that can be put together to equal 10. And that makes it a lot easier for them to solve mentally. So, excuse me, 5 plus 2 plus 8, the 2 and the 8 can be combined to make a 10. So 5 plus 10 equals 15. They may also see that in a word problem. So Spencer had 5 cookies, 2 cupcakes, and 8 M&Ms. How many sweets did Spencer eat? So then the students would take that story problem and turn it into the number sentence 5 plus 2 plus 8 and solve it just the way we did above. First graders are working on adding and subtracting within 100 using the knowledge of tens facts. So looking at this example, 38 plus 3, the students can break apart the 3 into 2 and 1. They're doing that so that the 2 can be combined with the 38 because they know that 8 plus 2 will add up to another 10. So the problem can be rewritten as 40, which is the 38 plus the 2, plus 1, which is the 1 left over from the 3, to equal 41. And it makes it a lot easier for the students to solve mentally. Moving into subtraction, looking at 14 minus 6, the students can use a similar breaking apart strategy. So taking that 6 and splitting it into 4 and 2. And the reason why we picked 4 instead of 3 and 3 is because 14 minus 4 will give us that 10 and make it a lot easier to solve. So we can rewrite the problem as 10, which is the 14 minus 4, minus the 2 that's left over in the 6 to equal 8. That can also be shown on a 10 frame where 14 circles are filled in and 6 are crossed out, or in a number bond where 14 is the whole, 6 is the part, and the students are trying to find the other part. Moving into second grade, students are going to be building upon all of those skills that they learned in first grade to fluently add and subtract within 100, add up to 4 two-digit numbers, explain why addition and subtraction strategies work, read and write numbers through 1000. And they're doing that by showing base 10 blocks, so the squares, the strips of 10, and the single cubes, writing it numerically, just the regular number, and writing it in expanded form. And they will also start to work with equal groups as a foundation for multiplication. So, second grade will focus on 3 different strategies for solving addition. So, the first one is solving by place value. Looking at the 24 plus 37, we will split into tens and ones. So, taking the tens from the 24 is 20, the tens from 37 is 30. So, we put together 20 plus 30 to equal 50. Then we can add the ones. 4 plus 7 equals 11. And when we put them together, get 61. Another way to solve this in second grade is to use a number line. And in kindergarten and first grade, the number lines were given to the students with the numbers already written on them. But once they get to second grade, they're going to have a blank line and they can put whatever numbers they need on the number line. So for this equation, I would start at the 24, and I'm going to do one big jump of 30 to get to 54 because I'm adding 24 plus 37. Then I need to add 7 more. So in this example, I just added by 1. So I did plus 1 plus 1 plus 1 plus 1 7 times until I got to 61. Another way this could have been done is 24 plus 30 gets to 54, plus 6 more would get to 60, plus 1 more would get to 61. Another strategy is making an easier problem. So because the students are so comfortable with their tens facts, we can take that same problem, 24 plus 37, and I'm going to take 3 away from the 24 and move it to the 37. Then I can rewrite the equation as 21, because I took the 3 away, plus 40, because I put the 3 into the 37, which equals 61. Second graders are also adding multiple add-ins, but they can use the same strategies that we just talked about. So if we're looking at 24 plus 36 plus 41, we can take the tens from each number. 20 plus 30 plus 40 equals 90. Then we can take the ones from each number. 4 plus 6 plus 1 equals 11, and put them together to get 101. We also add by place value using the base 10 models. So we can represent the 123 with a sheet of 100, 2 strips of 10, and 3 singles. And the 55 with 5 strips of 10 and 5 singles. When second graders are actually starting to solve with 3-digit numbers, they will have those blocks. They will have access to those actual blocks. So they can move them around on their desk, put the 100 together, group the 10s together, and group the 1s together to get 178. Moving into subtraction. So most of the subtraction that the second graders will do does not have regrouping. So when we teach second graders to subtract in parts, if they were to split both numbers, if they split the first number into tens and ones and the second into tens and ones, it would work because there's no regrouping. But when I taught third grade, a lot of the second graders were coming into third grade using that strategy, but it didn't work when we were regrouping. They would get the wrong answer and they would have to unlearn that strategy. So I tell all of my second graders, when you subtract in parts, you cannot split that first number. And then they just get into that habit. So we're looking at 67 minus 44, keeping that 67 together and splitting the 44 into 40 and 4. So 67 minus 40 is 27. 27 minus 4 is 23. This can also be shown on a number line, but instead of starting all the way on the left, we're going to start on the right. So I'm going to start with 67 and I'm going to subtract 40, do that big jump back to get to 27, and then subtract 4 more to get to 23. The students can pick whatever method they want that they feel comfortable with when solving on a number line. So some students who want to work with multiples of 10 might start with 67 minus 7 to get to 60 and then subtract that way. Some might want to get rid of the 4 ones first and do 67 minus 4. Some might want to start with 67 minus 10 minus 10 minus 10. And that's totally fine. As long as they're showing their work, they'll get to the same answer. The final strategy, which also happens to be my favorite strategy for subtraction, is adding up. So we are taking 67 minus 44, and using fact family knowledge, we're going to rewrite the equation as an addition number sentence with a missing addend. So I'm going to rewrite it as 44 plus blank equals 67. It's really important when solving this way that the students keep their work lined up. Otherwise, it's a lot of numbers and they might get confused as to which number they need to look at. So I would start this by doing 44 plus 6 to get to 50, 50 plus 10 to get to 60, and then 60 plus 7 to get to 67. Because all my numbers are organized and the ones that I added are right under the blank space, I tell my students to look under and circle all of those numbers that they added, and that's what goes into their answer space. So 44 plus 23 equals 67. The answer is 23. Lastly, second graders will start the foundation of multiplication. We teach them that the multiplication symbol means groups of. So if they see 4 times 6, it's the same as saying 4 groups of 6. And we show them this using array models. Think like a muffin tin that has an equal number of rows and columns. And they can remember rows if you put your arms out, like row, row, row your boat. And the columns are vertical. We think about a column holding up a building. Okay, so now third graders are working on fluently multiplying and dividing within 100, solving 2-step word problems using all 4 operations. And they also should be able to tell time to the nearest minute and solve word problems involving addition and subtraction of time intervals in minutes. So third graders will use something called the area model to solve multiplication. So here we will set up a box. On the left-hand side, I have the number 8. On the top, I'm going to split the 58 into 50 and 8, and then multiply across. 8 times 50 equals 400, and I'm going to put that in that box. And then 8 times 8 equals 64. I'm going to put that in the other box. Then we just add them together. 8 times 58 equals 464. We can also do this with a 3-digit number. So instead of having 2 boxes, we would have 3. So the 5 is on the left-hand side. The 279 is split into 270 and 9. 5 times 200 is 1,000. 5 times 70 is 350. 5 times 9 is 45. When we add all of those numbers together, we get 1,395. Third graders will also be solving multi-step word problems. So I have two quick examples here to show you. The first one, Mrs. Nelson wants to give 2 pencils to each student in her class. There are 24 students in her class. There are 6 pencils in each box. How many boxes of pencils will Mrs. Nelson need? So the students will do 2 times 24 is 48, and then they will use repeated addition. 6 plus 6 plus 6 plus 6 plus 6 plus 6 equals 48. So she needs 8 boxes of pencils. The other word problem says a small bag of marbles contains 32 marbles. A big bag contains 48 marbles. Ethan bought 3 small bags and 2 large bags. How many marbles did he buy altogether? So for this one, we are going to write the equation 32 plus 32 plus 32 plus 48 plus 48. And then we can solve it using the same tens and ones strategy. In third grade, we also use a number line to solve problems that require elapsed time. So one example may say Spencer's basketball practice started at 4:30 and ended 1 hour and 45 minutes later. What time did it end? So we would start the number line at 4:30, add 1 hour to get to 5:30, then add 30 minutes to get to 6 o'clock, and then add 15 minutes to get to 6:15. Another way this question may be worded is it will show an analog clock and say Spencer's basketball practice started at the time shown on the clock and ended 1 hour and 45 minutes later. What time did it end? Fourth graders are going to learn how to solve multi-step word problems using all 4 operations. Multiply a whole number of up to 4 digits by a 1-digit number and multiply 2 2-digit numbers, and find whole number quotients and remainders with up to 4-digit dividends and 1-digit divisors. So this is a type of word problem that a 4th grader will encounter. Logan saved $367 in June, $245.12 in July, and $305.05 in August. Then Logan spent $155.55 on school supplies and $67.05 on new clothes. How much money does Logan have left? So the 4th graders will have to add the money that was saved, add the money that was spent, then solve for how much money Logan has left. I chose to show you my favorite adding up strategy. So $222.60 plus what equals $917.17. So starting $222.60 plus 40 cents to get to that whole number of $223. Then we add $7 to get to 230, add 70 to get to 300, add 600 to get to 900, and then add $17.17, putting those all together to get $694.57 left. In fourth grade, they will also focus on multiplying two-digit by two-digit numbers using the area model. So this is similar to what they will work on in third grade, but instead of splitting one number by place value, they have to split both numbers by place value. So our 42 is split into 40 and 2. The 35 is split into 30 and 5, and we multiply across the boxes. 40 times 30 is 1,200. 2 times 30 is 60. 40 times 5 is 200. And 2 times 5 is 10. And when all of those are put together, we get 1,470. Moving into division. When fourth grade teachers first introduce division to the students, it's in a conceptual way. So what we're doing, our equation is 84 divided by 6. They may say, we have 84 Legos and we are separating them by color into 6 bins. So the students may have a manipulative, they may be making tally marks, they may be counting to take that 84 and split it into 6 equal groups. So they may do 10 in each group and have 24 left over, and then make tally marks and say 61, 62, 63, 64, 65, 66, splitting them into 6 groups until they end with the number 84 and see that there are 10 and 4 ones in each group. So the answer is 14. Once the students understand it conceptually, then they will learn the partial products. The partial products strategy. Okay, partial products. So this is similar to the area model. We're looking at 84 divided by 6, and we're going to set up boxes. So the 6 is going on the left-hand side, and the 84 is going inside of the box. The students are going to think about multiplication. So 6 times what would get close to 84? So 6 times 10 is 60. So they're going to write the 10 on the top of the box and subtract 60 from the 84 to get to 24. Since there's still 24 left, the students will make another box to the right and put the 24 at the top and do the same thing over again. 6 times 4 is 24. They subtract the 24 to get to 0. Then they would add the 10 plus 4 to get to 14. If the students weren't as fluent with their multiplication facts, they might say 6 times 2 is 12 and put the 2 on the top, subtract 12 from 24 and have 12 left at the bottom. That's totally fine. All they would need to do would be make another box to the right, do 6 times 2 is 12 again, subtract it until they got to the 0. And that's really the beauty with this strategy. The students can pick any number that they are comfortable with, and they know that they're not finished until they end with a 0. So this shows, again, 84 divided by 6 equals 14. All right, what questions do you have? Feel free to send me an email, call us, or reach out through our website with any questions. Thank you so much.